Hello, everybody. I hope you have a good day so far. Today, we are going to be talking about how to find horizontal asymptote of rational functions. Okay, so remember rational function have like a fraction of polynomials. Okay, so asymptote is the line that the graph of the function approaches but never touches. Rational function contain asymptotes. So in this example, you can see the vertical asymptote go up and down like this, and x equal -2. Horizontal asymptote, in the other hand, is the one that goes sideways. And also you can see right here is a curve that is a line that your graph get very, very close but never touch it, okay, or cross. So in this example below, we are going to go ahead and identify the vertical asymptote and the horizontal asymptote. So first, if you look on the first example right here on the left, we have the vertical asymptote is the one that go up and down like this, go straight, and then crossing your x-axis at this number, right? So every x value right there is gonna be exactly the same value. So we have x equals +2. Horizontal asymptote, on the other hand, is the line that go left and right. It goes side to side like this. So horizontal asymptote, and because it's crossing the y, all the value on here is going to be exactly the same, is 1. Okay, so y equals +1. Vertical asymptote on number 2, we have again looking at the line that go vertically like this and crossing your x-axis at -3. So we have x equal -3. Horizontal asymptote is the one that goes side to side like this, and then crossing your y at +1. So we have y equals +1. There you have it. This is how we identify the vertical and horizontal asymptote with the graph. Okay. So remember these lines, when you graph them on decimal, you're not gonna see it because it's invisible to the eyes. Okay. However, you can identify them with the algebra skill that we already learned in the past few days. Today, we are going to learn how to do it with simple rules. Okay, so here we go. How to find horizontal asymptote? By using this rule when graphing. So let us take a look. Horizontal asymptote. So we are going to compare the degree of the numerator, which the top. For example, this case, we have the 2x, and then we compare it with the degree of the denominator on the bottom. So speaking of degree, let us go ahead and review real quick about degree, okay? I'm going to put this one right here. So the degree of a polynomial is the highest power. For example, we have x to the power 3 plus x squared minus 3. Okay, so we will say the degree right here is going to be the number 3. It's the highest power or exponents, arranging usually from the biggest power, and then the second biggest, and then the last one. Okay, so that is a degree. So right here, the degree on the first one is 1, because that's the highest power. And then the degree on the bottom is 2, right? So we have the horizontal as y equals 0. If the degree on top and bottom is the same, for example, on the second example here, we have 2x squared over 3x squared plus 1. So this one have a degree of 2. And the bottom also have the degree of 2. So they are the same, okay? Then the horizontal asymptote is going to be the leading coefficient. You take the leading coefficient right here is 2, and then divide by the leading coefficient on the bottom, okay? So 2 over 3. Last case that we have is whenever that you have the numerator, the degree is bigger than the degree on the denominator. So here we have the degree is 3, and here the highest degree is 2. So we have that one is 3 over 2. So the top is bigger, then we have no horizontal asymptote. Okay, no horizontal asymptote. However, you are going to have a slanted asymptote or the oblique asymptote. But we just in algebra 2 right now, we are not talking about this kind of asymptote, okay? You are going to learn this one in pre-calculus, okay? So in order to best help you understand and remember these 3 simple rules, we have come up, the awesome math teacher had come up with this mnemonic device, okay? Here we go. The first one is bigger on bottom, or we call it BOBO. Bigger on bottom, y equals 0. You see, we take the first letter of each. And then the second one is bottom. Bigger on top, none. As you can see on the last example right here, you see, none. And then the last one is degree are the same. So we have that DC, that's DC. Degree are the same, then you divide the coefficient, just like the second example that we see right here, okay? 2 over 3 is on the front, we call them the leading coefficient. And then we divide them to find the horizontal because we have the same degree on the axis, okay? So that's it. We are going to go ahead and take a look at the next 3 example on the next page. So we practice how to find the horizontal asymptote. Here we go. Identifying the horizontal asymptote of the following rational function. So remember, we only focus on the degree, the higher degree on the top and the bottom, okay? So degree on the top, we have the degree. It's the highest power of x. So we have right here is 2. On the bottom, we have the degree is 3. So bigger on bottom, we have none. Bigger on the bottom, right? Bigger on bottom. Oh, sorry guys. Bigger on bottom is bubble, right? So we have y equals 0. And then, so that is a y equals 0, okay? The second example, we have the degree on top is 2. The degree on top right here is 2. Right? And then the degree on the bottom, if you see x alone, that means x to the power of 1, right? So we have the degree on the bottom is 1. So we already know the rule. If there's bigger on top, then it's none, okay? Bigger on top, then it's none. So this one is going to be none. We're not going to have a horizontal asymptote. The third one, let's see. X squared minus 4 over x squared minus 5x plus 6. This is yours, your teacher's favorite. They've been asking you to do factoring, huh? So again, to find the horizontal asymptote, we're looking at the degree of x. The leading degree right here. We have the top is 2. And the degree on the bottom, we have x squared, which is also 2. So if they are the same, right? The degree are the same, then we have divide the coefficient. So the leading coefficient of the top number right here, if you have nothing, that's a 1, right? Invisible 1 right there. And same to the bottom. So right here, we just have the y, the horizontal asymptote, y equals 1. Okay, so we have seen 3 different types right here. Now, we can always graph them on decimal and justify the graph. Okay, so let's see. The first one we said is y equals 0. The second one we say y equals none. And then the third one we have y equals 1. Let's check it out on the graph. Okay, check it out, check it out. Right here we have number 1. Number 1 said this one, x squared plus 2 over x to the power of 3 plus 5x. So this is how the graph looks like. Okay, as you can see right here, if we plug in y equals 0, then if this line will be right in the middle of your graph. You see the curve that it close to the curve, the two curves right here, but never touches. So we can confirm that one, okay? Number two, we have the second example is 3x squared plus 4 over x minus 2. So right here we have 3x squared plus 4 over x minus 2. So as you can see, we have the two curves so far away from each other like this, okay? So we don't have a particular horizontal asymptote in the middle right here. So we actually have a slant asymptote, but you're gonna learn about that in the pre-calculus, okay? So this one we say none. We only been asked to find the horizontal and we have none. So here we go. Let's go to the third one. The third one say x squared minus 4 over x squared minus 5x plus 6. And this is how the graph looks like, okay? But because when you divide the coefficient, you have 1 over 1. So let's go ahead and put y equals 1. And there we go. We have the value right in the middle of the graph right here. And the two curves, in red right here, they don't touch the horizontal, okay? So we can confirm by graphing that way. Okay, next, let us review how to do how to find the vertical asymptote, the whole, horizontal asymptote, and this time, because we have a horizontal asymptote, we also going to be talking about a range, okay? So let us take a look at this example. Identifying the following given the function. And they ask us to find all of this. Whole, vertical asymptote, horizontal asymptote. At what numbers is the function not defined? For what value of x, right? And then what is the domain of that? So let me zoom in a little bit so you can see better. So let us go ahead and get this one down. So here we have x squared minus 6x plus 8. Okay. Sorry, plus 6x plus 8. So remember we have the x factor. You can do like this or you can have other ways, it's fine. On the top, I'm going to put a number. On the bottom, we are going to have the middle number 6. So I'm looking for two numbers that add into 6 but multiply into 8. Okay, so normally some of your teacher will ask you to list it out all the number for 8. For example, 1 times 8, 2 times 4, 4 times 2, but that's repeating, right? So that's all they're having. And here we have adding into 6. Well, it have to be 2 and 4 in this case. So 2 and 4. 2 plus 4 will give you 6. 2 multiply with 4 will give you 8. So that works. Both of them have to be the same sign. All right, so here we're going to rewrite them as x plus 2 times x plus 4. And then we are going to do the same process to the denominator, the bottom, okay? We are looking at two numbers that multiply into 6, negative 6. But then when you add, you're going to get a negative 1 right here. So that's more negative. So we're going to have x negative 3. Sorry about that. X minus 3 times x plus 2. So we can see right here, negative 3 times 2 is negative 6. And then negative 3 plus 2 will give us the middle term, which is negative 1. So that works. So now, in order to find any of these, we need to look at the fraction that we just worked out, right? So in here, we can see that x plus 2 and x plus 2, they are the common factors, right? So we can cancel them out. These are called a hole, okay? It's gonna create a hole on your graph. And you need to solve for x for that. So we are going to go ahead and put that one, x plus 2. So set the factor equal to 0 and solve for x, okay? So on here, all you have to do is subtract the 2 because the 2 is being added to x. So we subtract 2 both sides and we're going to have x equal negative 2. So that's the whole, okay? X equal negative 2. So let me go ahead and write this right here. So before I forget, vertical asymptote is gonna be the factor that's been left over at the bottom, right? So this is, we're gonna label them vertical asymptote. Again, we are going to set it equal to 0 and solve for x. So add 3 both sides, we have x equal positive 3. So we have the whole is x equal negative 2. The vertical asymptote is x equals 3. Now let's find out the horizontal asymptote, right? So the horizontal asymptote is going to be the, we're looking at the degree of x, right? The degree of the fraction right here. So on top, we have the degree is 2. On the bottom, on the denominator, we have also the degree is 2. So remember the rule that we have earlier? Yeah. Degree of the same, divide the coefficient. Degree of the same, divide the coefficient. Degree of the same, divide the coefficient. So now we're looking at the coefficient. As you can see right here, we have the coefficient right here. Leading coefficient on the top is 1. Leading coefficient on the bottom also 1. So when you divide it up, we're going to get y equals 1. And of course, you can always grab this one in the graphing calculator and confirm for yourself, okay? Now, the function is not defined for two numbers. So remember earlier they asked us to solve for the whole and the vertical asymptote? Guess what? Those two numbers in the bottom is gonna make your graph undefined, right? If you plug it in, your graph is gonna be a number defined for 0. And we know that's a no, okay? It's gonna be undefined. Don't divide by 0. It's an asymptote. Okay, so in this case, we have two values of x that your graph cannot equals. That is x equal negative 2 or x equal 3. In other words, they are the vertical asymptote and the whole. Okay, so your domain is going to be all the real number except those two. X cannot equal to negative 2. X cannot equal to 3. Okay, so that is the condition for domain. The range, in the other words, the range is represent your y value, right? So all of your on the graph, or all of this, the only condition for the range not to equal is the horizontal asymptote, right? It can get very, very close, but it cannot equal to the asymptote. So it's gonna have all real numbers, but y cannot equal to 1. Just like how the vertical asymptote will make your graph undefined, the range also have the same condition. Can be any number in the world except 1. Okay. So asymptote is just like think of it like a electric fence. Okay, you can get very, very close, but you are going to get electrocuted if you touch it or cross it. Okay, so on the next one, we are going to take a look at the graph so we can confirm it, right? Here we go. I already graphed it for you. It looked like this. So as you can see right here, we have a hole at negative x equal negative 3. There's a hole right here. And then on the graph, we can draw the vertical asymptote at x equals positive 3. Okay, this is the vertical asymptote here. And then the horizontal asymptote, let me use pink for that. Horizontal asymptote is the line that go in the middle. And we said earlier it is y equals 1. So as you can see, it's go right in the middle. It goes side to side in the middle of the curve, right? So we can confirm for ourselves that, you see, the range is going to be all the way to the infinity right here, up until 1. Y equals 1, x equals 3, and right here the whole at x equals negative 2. So 3 condition right there. Okay, so that's it for today's lesson. I hope that you learned how to do horizontal asymptote, how to find with 3 easy rules right here. Bigger on bottom, y equals 0. Bigger on top, none. If the degree are the same, you divide the coefficient. Okay, there we go. When in doubt, make sure to go to your trusted friend who is decimal calculator. Remember to grab decimal like using the keyboard right here, so it can give you all the function, okay? That's including the fraction, the x, square. You can find all kind of function right here. Okay, so I hope you enjoyed today's lesson and keep growing and learning. Have a good day. Bye.